Hey, you guys. Sorry I can't be at school with you guys today. I'm actually heading to Kansas City this morning for a wedding. So I wanted to go ahead and give you some notes for today. We really don't have time to get behind just because I'm not in class. And then after you get these notes and go through the examples and all, then you can work on your homework assignment in class. And remember, as always, feel free to work together, help each other on the homework. And I know that Mr. Mao is also a math guy, so I'm sure that he's happy to help you as well. So let's get started. First of all, solving differential equations. You know, we've done this before. We've answered questions where it simply says solve the differential equation. And basically what that means is that we're going to find the original function, original function, assuming that you are given the derivative. And like I said, we've done this before. A basic okay, obviously I didn't spell that right. Derivative. Sorry. Okay. We've done that before. So look at my example. It says find the general solution to the differential equation if dy dx equals 2x. So when they say find the general solution, that means I want to find the original function y equals what? And the reason it's a general solution is because there's going to be a plus c, right? So it's going to be kind of the generic form of the equation because we don't know what that constant is. And like I said, we've done this before. If I want to find y, then really what I'm actually doing is it's kind of like I'm integrating both sides, right? The idea is that y, because the integral of the derivative of y is y, and then on the other side, when I integrate the 2x, I'm going to get x squared and then my plus c. And that's, you know, kind of the basic way we looked at it before. Well, here's the issue. We're not going to do the exact same thing over again. Here's the issue. What if I have a differential equation that is in implicit form? And remember, implicit form means that you have the x's and y's mixed up. Okay, so in other words, I'm saying the derivative is 2xy. So how can I integrate this, right? How can I integrate this if I have both x's and y's? And the answer is you can't. You can't integrate if you have both x and y mixed up. So what we have to do is kind of follow this protocol that we have below here. And what I'm going to do is I'm going to go ahead and list out the steps, and then we'll go through an example that kind of takes you through those steps. Okay, so the first thing you have to do, since you can't integrate if there's both an x and a y on the same side there, is you're going to have to separate the variables. And kind of from now on, this is how we are going to refer to this type of situation. We're going to call this separation of variables. So first thing you want to do is separate the variables, and I'll show you down below how you do that. Once you have them separated, meaning the x is on one side and the y is on the other side, once you have them separated, then it's back to what we did before. You can integrate both sides, okay, and then for your final step, make sure you actually have solved for y. Right? Because if I want to find the general solution, then I want to solve for the original function, so solve for y. Okay, so take the example that I mentioned above. I have dy dx equals 2xy. And when I say separate the variables, I'm not just talking about the 2xy, separating that x and y, but I'm also talking about this side where you have a dy over dx. I need to separate the dy dx as well. So let me kind of rewrite that down below here. I have dy dx equals 2xy. Now here's the thing. Whenever we integrate, remember up above, I kind of fudged this a little bit because really we'd never just integrate 2x. We would integrate 2x dx, right? Okay. Well, what I need to do is somehow I need to move the dx over to that side. So down here, when I say separate the variables, I'm going to think of dy and dx as two separate terms. So if I want to move the dx up to the other side, I'm going to multiply both sides by dx. That's going to move the dx over here. But remember, at the same time, I don't want this y here. So since this y is being multiplied, to get rid of it, I'm going to divide by y. So what I actually have is, let me get rid of all my junk in the way here. What I actually have now is I'm going to divide by y. So on the left, I'm going to have a 1 over y, and I want to keep the dy on that side. But on the other side, where I already had the 2x, that's going to stay there. I'm going to, like we said a minute ago, I'm going to multiply by the dx, and that's going to bring the dx over here. So that easily, I have separated the x's and y's. Now, something I've kind of failed to mention, and sometimes it's an issue and sometimes it's not an issue, is when we say separate the variables, you can only separate by multiplication and division, meaning you can multiply both sides or you can divide both sides. But you can't add or subtract to both sides. It won't work that way for various reasons, but it just won't work that way. So now that I have the variables separated, so I've done the first step, now I'm ready for the second step where it says integrate both sides. Okay, well, if I want to integrate both sides, I'll integrate this side with respect to y. I'll integrate this side with respect to x. And here's what I'm going to have. On the left side, if I integrate 1 over y, I'm going to get natural log of the absolute value of y. And yes, it matters if I have absolute value, plus c. And on the right side, when I integrate 2x, I'm going to get x squared plus c. Now, something to keep in mind, because when you integrate, you have this plus c, I just generically used a c. Just because I have the same c on both sides doesn't mean those are the same number. In fact, you know what I think I'll do? Imagine if I were to move this plus c over to this side. Okay, when I subtract, that's not going to give me 0 because, again, we don't know what these constants are. But basically, when I move it over here, I'm going to combine them just into one constant. So as a result, I think what I'll do from now on is, instead of putting that plus c on both sides, I'm just going to always put it on the right side. And I'm going to assume that this plus c counts for the one on both sides being combined. Okay, so I have now integrated both sides. And then the last step says I need to solve for y. Okay, well, how am I going to solve this equation for y? Well, the only way to get y out of the natural log, two different ways to look at it. You can think of it as changing it to exponential form, but I think the way you learned last year in pre-AP pre-calculus is the idea that basically you're gonna put in a base of e on both sides. So now you have e to this exponent equals e to this exponent, right? Because on the left side, if you raise e to a natural log, isn't there kind of a shortcut that those kind of cancel? And so now the left side just equals y. Now on the right side, you have your e to the x squared plus c. And notice that plus c is in the exponent. Yes, it matters. It's in the exponent. So I have e to the x squared plus c. Now I want to show you something that you're going to want to use this concept quite a bit in these problems. Think about this. How do you get addition in an exponent? Well, isn't that the same as saying you have e to the x squared being multiplied by e to the c? Because if you multiply the same base, isn't that when you add your exponents? Okay, you might say, well, why do you want to do that? Well, because look at this. If e is a constant, and you raise that constant to another constant, wouldn't this just be one big constant? So really, I can think of this as just some big constant being multiplied by e to the x squared. So the idea is when you have e and there's a constant in the exponent, that's the same as saying you have a constant, that constant out front. Okay, so here's what I found. I have found the general solution because I have a c, right? My general solution is y equals c e to the x squared. But what did the directions say? They said find the particular solution. Okay, well, how is particular solution different from up here when we found the general solution? Well, particular solution means they must be giving you some ordered pair so you can find your c. So I'm going to use this ordered pair 0, 2. I'm going to plug in a 0 for x and a... Yes, I'm at school. Can you hear that? Anyway, unfortunately, she didn't give us a funny announcement this afternoon like she usually does. So I'm going to use this plug in 0 for x and plug in a 2 for my y to see if I can find the c. So I'm going to kind of bring that up here. So I'm going to say y, which is 2, equals, I don't know what c is, e to the, well, if x is 0 and I have 0 squared, wouldn't that be e to the 0? And since we know e to the 0 is 1, that means c must equal 2. So what is my actual particular solution? Well, y equals c, which we just decided was 2 e to the x squared. So this is the particular solution to the differential equation. Now, you may be thinking to yourself, well, that's a lot of steps. And you're right, it is. And it could be that this is a multiple choice question. This particular one is not too terribly difficult. This could be a multiple choice. But it's pretty likely that this could also be a part of a free response. And the cool thing about these in free response is, yes, this would just be one part of the free response, but this would be anywhere from 4 to 6 of the 9 points of the free response. The way they usually grade these is they always count 1 point just, 1 point would go down here, 1 point just for getting a correct separation. And then depending on if they want this to be, like a 5-pointer versus a 6-pointer or or maybe even a 4-pointer, sometimes they will give you 1 point for each correct integration. When we integrated 1 over y, we got natural log of y. And when we integrated 2x, we ended up with the x squared. So 1 point for natural log of y, 1 point for x squared. But they also tend to give 1 point for remembering to put that plus c right there on that line. So that one line actually got me 3 points. And then usually they give you 1 point for knowing to plug in the ordered pair that you're given. Not necessarily for finding the c correctly, but for knowing to plug in. And then you could get 1 point for your final answer. So there's a situation where that one part of a free response could be worth a total of 6 points. So this is one that we definitely will practice quite a bit. It's very doable to get that 6 points on a free response. Okay, so let's go on to another example. So find the equation of the curve. Okay, it doesn't say find the particular solution. Find the equation of the curve that satisfies this derivative equals 1 over xy and passes through this point. Well, even though it's not worded the same, isn't that what they're asking me to do? Aren't they asking me to find the original equation, y equals whatever? And the fact that they gave me an ordered pair means I'm going to be able to find the plus c. So I'm going to follow the exact same steps that we did on the last one. Okay? So let's take a look at the differential equation that I have. Now remember, I definitely want to separate the dy and the dx. So I'm going to have the dy on the left equals, I'll leave a little space, and I'm going to have the dx on the right. So how can I move this y over to the left side? Well, it's in the denominator, so why don't we multiply by multiply by y. And in this case, there's already a 1 over x on the right side. I'm just going to leave it. So I've separated my variables. That would be the first point. Remember, the second step is to integrate both sides. Okay, so if I integrate the left side, well, the integral of y is y squared over 2. And remember, instead of writing plus c, I'm just going to combine that plus c with the plus c I get over here on the right side. So the integral of 1 over x is natural log of the absolute value of x. And then I'll put my plus c. Okay? Now this time, I don't need to do that, make e be the base of both sides, because when I solve for y, if I solve for y, couldn't I just multiply by 2 and then take the square root? So if I multiply by 2, y squared is 2 times the natural log of the absolute value of x plus c. Now here's the thing. If you want to distribute the 2, you can. You don't have to. It doesn't matter. And then if I'm actually solving for y, I'm going to say y is the either plus or minus the square root of 2 natural log of x plus c. Now, that's my general solution, right? Because that's just the generic plus c. If I want to find the particular, the actual equation that goes through this point, I'm going to need to plug in my ordered pair. So I'm going to plug in my -4 for y. Let's see, I'll do it up here. So -4 goes in for y equals, now for now, I'm just going to kind of ignore this plus or minus and we'll come back to it. So I have the square root of 2, now the natural log of 1, and then my plus c. Well, what's the natural log of 1? It's 0. So what I have is that -4 equals the square root of c. And if I want to solve for c, wouldn't I just square both sides? So if I square both sides, I'm going to have that c equals 16. Okay, so my actual equation that they are looking for would be y equals, okay, so now how do I know whether or not I want the plus or minus? Well, here's how I know. Look up here at my ordered pair. If the y has to be negative, and down here I'm saying y equals a plus or minus, well, what is y? Is y plus or is y minus? Well, we just said y is -4, so I'm going to choose the negative to go out in front. So y equals negative square root of 2 natural log of x, and then instead of plus c, we're going to say plus 16. And remember that plus c in this case was under the square root. So there's the actual function. Now, just to kind of show you another way they tend to grade these, like I said, you get 1 point just for separating correctly. On this one, it might be that they give you 1 point for integrating the left side correctly, 1 point for integrating the 1 over x correctly, and maybe instead of giving you 1 point just for the plus c, maybe that 1 point is for not only knowing that there's a plus c here, but also knowing that you need to actually plug in your ordered pair and find c. So maybe that 1 point is for doing both of those correctly. And then maybe the final point is for actually writing your equation. So in this case, this would be a situation where it would be worth 5 points instead of 6. Very possible. Okay, one last example. And a lot of times this is kind of more of a multiple choice example. So basically it says write and solve the differential equation. So first I have to write a differential equation, meaning a derivative equation, and then they want me to solve it, meaning integrate both sides. That models the verbal statement. The rate of change of r with respect to t. So the rate of change of r with respect to t is inversely proportional to the square root of r. Okay, well, inversely means fraction or reciprocal, so it's like a 1 over. So proportional to means times a constant. So instead of saying 1 over, it's kind of like saying constant over. So inversely proportional to the square root of r. So square root of r. Now, for my constant, why did I use k instead of c? Well, because I know when I integrate, I'm going to have a c, and I didn't want to get it mixed up with this other constant k. Okay, so I've written the differential equation. So now let's follow the steps. First, I need to separate the variables. Now, what are my variables? Are they k and r, or are they t and r? Well, this is a derivative of r with respect to t. So what I'm separating is the r and the t. So I'll keep the dr on the left. The the dt is going to come to the right. So in order to get the square root of r over here with the dr, I'm going to multiply by square root of r. And so the question is, if k is just a constant, like a 2 or a 3 or a 5, do I put it on the left with the r's, or do I put it on the right with the t's? And the answer is it doesn't matter at all, whatever you want to do. I tend to leave it over on the right side because I figure it's less to have to get rid of when you're solving for r. Okay, so I've separated my variables. Now I'm ready to integrate both sides. So if I integrate r to the 1/2, it's going to be r to the 3/2 times 2/3. Now remember, k is a constant. So if I integrate k, isn't it just going to be kt? And then don't forget your plus c. Okay, in this case, I need to solve for r. So if I solve for r, let's see. Not only am I going to multiply by 3/2, let's do that first. So r to the 3/2 equals 3/2 times kt plus c. But in order to solve for r, in order to get rid of that 3/2, I think what I'll do is I'll raise both sides to the 2/3. Won't that get rid of the 3/2 here? Because when you multiply your exponents, wouldn't you just have r to the first equals, and then this whole mess, 3/2 kt plus c, the whole thing raised to the 2/3. Now in this case, do I need to plug in and find the c? Well, no, they don't give me an ordered pair to do that, so they just wanted the generic form, kind of a general solution. Okay? So basically, those are several examples, and what you'll see in the homework, and if you just look on the calendar, you'll see that it has you do a worksheet. So if you look at the worksheet that you got in class today, I think make sure you notice one side of the worksheet is day 1, which is today's, and then the other side of the worksheet will be day 2. We'll do that next time. So hope this helps. And do your best. Don't forget, you're going to be working on this homework in class today on Friday. It is due during our next class, which would be next Tuesday. And also remember, you'll have an online quiz that is due Monday night. So good luck, and I will see you next week.